Is this thing on? 1 second, let me see. Why is that I'm so hard to find on here? Whatever. Have a good. Oh, cool. It's okay. Anyways, hi guys. Sorry I just started. So just great. I'm gonna be doing calculus because why not? Okay, let me find some practice problems. Hmm. Okay, so let me see. I haven't learned integrals yet, but yeah. Okay, 1 second. Uh, like, what was the quotient rule again? I can't remember. Anyway, so hey, I need to go. Oops. I'm gonna get some paper real quick. Be right back. Be quiet. Where's the pencil? Okay, so okay. I don't remember the quotient rule, so I'm just gonna see. Okay, so the derivative. Okay, so 1 second. Let me see. D over. I don't remember the quotient rule, so I'm gonna skip number one and do number two. D over dx, negative sine x squared, and 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 derivatives distribute. So and the derivative would be. Wait, what was the chain rule again? I don't remember. This is not full. Okay, here it is. Okay. Okay, 1 second. Let me write this down. Okay. So f of x plus g of x. Okay, so and then the product rule. G of x, and then take that and then take its derivative. That's plus u plus f of x times g prime of x. Why why do I know this? Like I just don't remember. I didn't bring my thing. Yeah, derivative f prime g. Okay, f prime of x times g of x times. Oh, why do I keep on writing times across when that's just x? And then you subtract. Yep, and y. Okay, and then equals u prime. Oh wait, f prime f prime v of x times g prime of x. That's interesting. Anyway, so now let's get back into this. Okay, so okay, so okay, okay. So the derivative of the first one equals negative. Okay, negative 4x squared divided by 2x cubed, I think it was. No wait. Okay, divided by x to the 6. Okay, 1 second. Negative 4x squared, okay? So f prime of x of f prime of x is 0, since that's so we can just ignore the first term. And then the second term, g prime of x times f of x, the derivative of that is 3x is th- is 3x squared times negative 2, and so I made a mistake. It's negative 6x squared, not negative 2x squared. And then divided by that by gx squared, which is x to the 6th, and then we can take out all of this. X squared and x to the 4 can cancel, and x to the 6 can cancel out. So the derivative of number 1 is negative 6 over x to the 4. Okay, so so next question: negative sine x squared plus cosine squared x. I'm not gonna make cosine squared x and not cosine x squared. I mean, it sounds ambiguous, but like, just write brackets around x to signify that it's a function. Anyway, okay, cosine x squared, the derivative of that. Okay, so how do we do? Okay, so let's calculate the product of this. Okay, negative sine x squared. Okay, f g of x. Okay, so f prime g of x equals negative cosine negative cosine 2x times the derivative of g. So that's negative 2x. Wait, no, wait, never mind. Negative cosine x squared 2x negative 2x times cosine of x squared. and then you add the cosine squared x. So, okay, 2. Okay, negative sine. Okay, so cosine. Okay, so the derivative of cosine is negative sine, right? So negative sine of 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 cosine of x times negative sine of x times sine of cosine of x. Is that correct? I think it is. And then you just add the two terms. Okay, so negative 2x cosine of x squared to, wait, plus plus negative minus minus sine x times sine cosine x. Oh, and I ran out of paper to write on, but that's okay. So the answer is negative 2 cosine x squared minus sine x times sine cosine x. Is that correct? I think it is. Whatever. Who cares if you're right on the internet? They only care if you're confident that you're right. Anyways, the next one is 8x divided by x squared plus 2 over 2. Squared, I mean, whatever. So 8x. Okay, so the derivative of that is just 8. So the derivative of that is just 8. Okay, so we can plug in 8x. Okay, so f prime is 8. 8 times x plus 2 squared. And then you use okay, 1 second. Let me write this on a better piece of paper. Okay, 8x my squared my plus 2. Square that. If we square both sides. Wait, no, that's not how that works. Wait. A plus b squared equals 2x squared. 2x squared. Okay, so 2x squared plus 4. x squared plus 2, and then you square all of that. Okay, so that's the first term in there. Okay, then you subtract that. Okay, what's the derivative of x squared plus 2 squared? Plus 2 squared. How would we calculate this? Well, the derivatives add up, and 2 is a constant, so you just take the derivative of x squared squared, which is x to the 4, which is 4x cubed. 4x cubed plus 64 plus 64x x plus 64x cubed, since that's 8x, and then just take the stuff. I don't. Wait, let me recalculate this. Okay, so the derivative of that is just 8, and then the derivative of the bottom part of number 3. That's 8x cubed, since derivatives take that. And so you just take the derivative. Okay, since derivatives, we need to calculate the derivative of the part of the parentheses in number 3 first. And since derivatives go, like, add properly linearity, and then 2's derivative is 0 since it's a constant, we can just ignore that. So x squared squared, that would be just x to the 4. And then we just calculate the derivative of that, which is 4x cubed. And we multiply that by 8, and then we get 64x cubed. So we subtract the first term that we got, which was 8 times x squared plus 2 squared. And then, x squared plus 2, and then square all that, and then you subtract 64x cubed. And then finally, you divide it by gx squared. Okay, x squared plus 2 squared, x squared plus 2 to the 4. Divided by x squared plus 2 to the 4. Okay, so our total for... I'm not simplifying this. I hate this. Anyway, it takes forever. Anyways, next question. 20x times 2... Wait, this... I'm just gonna assume that the tesseractation only applies... That the power to the 4 only applies to the part of the parentheses, since exponentiation takes time property. What kind of math? Whatever. Okay, so first we need to calculate. Okay, so product rule. Okay, so derivative of this. Okay, so take the product rule. Okay, so the derivative of the first part. Okay, so 2x plus squared plus 1 to the 4. 2x squared plus 1 to the 4. Man, I really wish x plus y squared equals x squared plus y squared. Sadly, exponents don't work like that. They're just stupid. Anyway, so let's see. I'm not simplifying any of this. Okay. Next part. Okay, this is g. Okay, okay, g prime. Okay, g prime of. Okay, g prime. Okay, what's the derivative of this? Okay, so. Oh, 4 times. Okay, 4. Alright, 4. Okay, 1 second. 4, 2x 2x squared plus 1 cubed. And then you multiply that by the first part, which was 20x, times 20 equal. Okay, so you can just put like 80x. 80x, since the derivative was, since you're multiplying it by 20x and you got 4, so that will be 80x. And then we just multiply this by tat, and then you get it. And there you have it. A bunch of calculus practice problems solved. Because why not? Okay, so the derivative of the first, it's -6. Wait, I forgot what it was. Whatever. Let's get it for fun. Because I'm insane and should belong in a mental hospital. Oh wait, no, never mind. Okay, so the correct answer for that is -6 divided by x to the 4. Okay, and the second one, that's 1 second. Where did I write this? I think it was negative sine x times negative cosine x. No, wait, that can't be. If it could be, then it would be, and thus it can't be. I think it was negative 2x cosine squared or something. X squared. Oh, right. Negative 2x cosine of x squared minus the sine of x times the sine of cosine of x. That's simple, totally. I'm gonna hate high school. Anyway, okay, next one, 8x over x squared plus 2, and then square all that. And by that, I mean the stuff in parentheses. So anyways. So, wait, what did we get? Oh, I think we got... Oh, I think... Oh, right. We got 8x squared plus 2 squared minus 64x cubed divided by x squared plus 2 to the power of 4. And then the final one we remember, it was 80x 2x squared. It was 80x 2x plus 1 cubed times 20. 20 times 2x squared plus 1 to the power of 4, I think it was. Can't read. Anyways, I hope you like this calculus. I know you probably didn't, but I don't care about your well-being. Anyways, bye.